Bismillahirrahmanirrahim. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Uh, I will discuss today the technique for goal programming in solution of civil engineering problem. Uh, this is the contractor objective for maximum profit and minimum expenditure. Uh, while explaining you these content, I must remind you that my focus is towards giving you the application of particular technique of operation research in civil engineering, and that's why I'm least bothered to explain you what is goal programming or what is transshipment problem, and I always solve it using Excel solver, which is the easiest way to get your answer instead of solving it with simplex method. So let's begin today, and we have to consider an example where a contractor is expecting maximum profit for lease expenditure as illustrated in the table. We have to calculate the minimum expenditure using this goal programming concepts. So let's see what this table is all about. Is bridge, the three infrastructure project, bridge, building, and highways, and they are being abbreviated or being supposed as X1, X2, and X3 respectively. The project duration here is 4, 3, and 2. Materials required is 20, 40, and 50, and that's be around 100. Profit in million USD 465 and greater than equal to 25. By now, we must know that goal programming consider the deviation, and that's why we have D1, D2, 3 for each of the constraint. This D1 can be positive and D1 can be negative. So that's why we have given that for the first duration can be he will be penalized if he exceed that 10 years limit on these projects. And similarly, he may get penalty if between -4 and 12 means he can have material range between -4 tons to 12 ton positive, and he can earn, he's expected to earn at least 12 million US dollar of the profit. So when we summarize it, we use variable x1, x2, x3, d1 plus d1 plus, d1 minus, d2 plus and d2 minus, and d3 plus and d3 minus. Now, the values, this is blank because we want an iteration from solver function to calculate these values for us. And the coefficient we can say for profit is D1 plus will have 10 for Z of objective function, minimum Z function, 12 for D2 plus, as we can see from this there, and negative for D4, 4 for D2 minus, and we say this, you expect that this can be more than 12, so you can write 0 here and 12 here. Anyhow, it is not going to make a difference whether you write it here or one of this will be 0, and this objective function will be the product of these these values, as you can see, sum of product of B12 and B15 to J15. Now the constraint, we have 4, 3, and 2. Again, we have what we do for D1, we have a negative coefficient of 1. And for D1 negative, we have positive. So that's why we'll have, obviously, since this is constraint 1, so there will be no value for D2 and D3. That's why it's 0. And this is the sum product of these unknown variables. You see, these are known variables and these value. Similarly, and we want this to be greater than equal to this value. Similarly, 20, 40, 50. Now, since this is D2, that is that we will write 0 both of them, and we'll have negative coefficient again for plus and positive coefficient for minus, and again D3 is 0 because this is constraint number 2. For constraint number 3, we'll have this coefficient 4, 6, and 5. Now we'll have D1 and D2, both of them will be 0, while D3 and plus and minus will be this one. So these are the constraint. And now we formally solve this using this solver function. So I'll use solver function. The objective is to minimize this value. We will change this value, and obviously there's a constraint here. So we solve it and just press solve and we'll get the value. And that's it. This is 108 minimum dollar cost of this project. So this is what goal programming and how it is being solved using solver function is explained. Thank you very much for your kind support and watching this video. Inshallah, I will try to have one more problem, maybe 2 problems, solving using other techniques in operation research. Bye and take care.